So my name is Konstantin Babi, and today we're going to have a nice and interesting talk by our colleague Abderrazak. He'll introduce himself in a while. And welcome everyone to today's meetup of the Malaga NET Community. So Abderrazak, the stage is yours. Please move on.
Thank you so much, Konstantin. Okay, hello everybody. So I'm Abderrazak. I'm a senior .NET developer. So today we're going to talk about reactive extension. It's a big title about, or in general title. So we're going to talk about .NET or RX.NET exactly. So my name is Abderrazak. You can call me Abdu. So I'm ex graphic designer and a senior .NET developer. I'm enjoying programming, working, traveling, and reading books, etc. Okay, so I will start my presentation. If someone have a question, so we have a reserved time for Q&A session at the end. So let's start with a reactive programming introduction, or to get an overview about reactive programming. So the origins of reactive programming can probably be traced to 1970s, I think, or even earlier. So there is nothing new about the idea about the reactive programming itself, but they are really resonating with something in the modern enterprise. Okay, so the resonance has arrived. Sure, it's not accidentally at the same time as the rise of the microservice architecture and the ubiquity of multi-core processors. So it is a programming paradigm that promotes an asynchronous, non-blocking, and event-driven approach for data processing. So reactive programming involves modeling data and events as observable data streams and implementing data processing routines to react to the change in those streams, okay? So it's simply to program using and relying on events instead of the order of the line of code. Usually this involves more than one event. Sure, we are talking about a collection or more one event are interacting between themselves. And those events happen in a sequence over time, okay? So in reactive programming, everything can be streamed as, can be treated as a stream of data, okay? So why we use reactive programming? Sure, about the maintainability of the code itself. So it will make the code more robust, easy to extend for later use. So reactive programming makes the code a lot more maintainable. This is the big line, is makes the code more maintainable. Sure, from the what and why we can answer the question when, okay? So why RX? So the modern applications must react to streams of data such as user and system events, okay? So also I like the internal messages and also for example, the sensor inputs, etc. So the reactive extension, or RX, it is a .NET library containing a lot of operators that you can compose together to build a reactive client and server-side applications, sure, to handle events asynchronously in a way that maximizes responsiveness of the application, resiliency, and elasticity. Okay, so the users of the application that we develop, so they expect real-time data. Okay, so as a developers, we demand fire and forget messaging, sure, and we don't want to be blocked waiting for a result. Okay, so we want to have the result pushed when it is ready. Okay, even it's better when working with the result sets. We want to receive individual results as they are ready. So we don't want to wait to the entire set to be processed. So before we see the first row, sure. Actually, we need tools to interact or to react with pushed data. One more thing I want to add here about the LINQ itself. It is integrated to the C# language, sure. And you could think of Rx as a link to events. Okay, so Rx we can see that Rx it is as a link to events. So LINQ will allow us to transition from other paradigm into a common paradigm. Okay. So the good news is that the rx.net it is a part of .NET 5. Okay. So we can see here an overview about the Rx, the domains, application, etc. Good. So let's be in an action.
I would say the key point to notice is that it's a part of .NET 5 BCL, right?
Please continue. Could you repeat?
Yeah. I just wanted to help a bit here. I'm suggesting to take a note that it's a part of .NET 5 BCL. Oh, yeah. So yeah. It's kind of a standard thing to know already.
Thank you, Konstantin. So, yeah, it's integrated under the system.reactive namespace in the .NET 5. Before the .NET 5, they comes in separate NuGet package, separate library. Thank you. Okay, so let's be in action. We have three samples: load balancer emulation, Drawboard, and at the end, if we have enough time, so we can I can present the NuGet search example after the QA session. Okay. So the first sample is load balancer demo. So we have a load balancer, a set of services. We want to ping these services and wait the reply. Okay. We take into consideration the services that replies within the timeout, as we can see here. Okay, give me a sec to share the sample itself. Good. Okay. This is the load balancer sample. So let's start from the program entry point. Okay. I implemented the load balancer samples with two approach, or with Rx and without Rx. So with tasks, so task-based and Rx-based. So here we have a set of services as a service mock, okay, and the emulator. Let's start with the Rx-based emulator. Okay, execute the sample. Oops, I have to share the whole screen. Give me a sec, please. Yeah. Oops. Good. Here we are. So the load balancer being is all the services. So we have here responded in time, the BHGDA. Okay. And it's
I'm sorry. Yeah, I would suggest to show alongside the slide and the execution, so it makes easier to understand.
All right, let's do it. So where is the Okay, so it's repeat with time. After a period of time, it's repeat to being the services and catch the services that replies within the timeout, etc. Okay, so let's have a look on the code itself. The task-based versus Rx-based. How we did it with Rx. Okay, here we have a set of observables. The observer, it's a term comes from the pattern of observable, and it is a type inside the Rx library. So this is the set of services. Okay, we have a kind of observation policy here. So we have to take a specific number of services or within a timeout. So we buffer. We see the buffer do all of these are operators of the Rx. Okay. This part is just to print a divider in the console. Okay. Another observable here is delay. So we have to put a delay between each repeat cycle or iteration. Okay, so we apply here the observation policy and just do repeat the observation. Okay, it's clean with the Rx. We don't see here a global status, okay, or global variable. Let's have a look about task-based. Okay, let's see the task-based in action. Firstly, the task-based do the same thing as the Rx-based sample did, but implemented with tasks without Rx. Okay, so let's have a look about the task-based sample. Yeah, if you see here, the Rx-based, we have the same method here, start async, and in the task-based start async. Okay, but here I started with a while loop in order to implement the repeat of observation policy. So check services. Okay, so here we have the set of services. Okay, here we have a lot of global variables, counters, and cancellation tokens in order to cancel tasks, etc., and set a concurrent bag to keep the services that replies within the timeout, etc. So this is with task. I did my best here to make it clear and small. Okay, so finally we have to wait the tasks or the services, all the services, if all the services are pinged or timeout. So we have to go out one of these conditions if satisfied. Okay, this is a task-based sample. Okay, let's go to the second sample.
Razak, do you want to allow questions at the end of the session, or maybe someone wants to ask something?
Yeah,
Please.
at the end of the question, yeah, I mentioned that.
Okay, sorry.
Yeah.
Yeah, please move on. I'm sorry, I'm just trying to help you.
Okay. Yeah. Here, the load balancer demo. So let's go to the Drawboard demo. Okay, here we have Drawboard demo. Sorry, I have to resize the window. Okay, good. Okay, so as we said before, everything with Rx treated as a stream. So the mouse down event is stream, the mouse move stream, and the mouse upstream. We have 3 streams here. Okay, so as we see here, I draw this line with Drawboard. So the first we have to click in order to start drawing. So this is the mouse downstream. With time goes with time. The second one is mouse move stream. So we can see here all the time the mouse are moving on top of the Drawboard. So it starts with the white cycle here and end with the white cycle. Okay. And finally, the mouse upstream. So when I finished up the drawing of this line, so the mouse upstream picked this one event. Okay, we can see the sample itself here, the code sample. Give me a sec to share my screen. Yeah, it is good to put it side by side. Yeah, this is the Drawboard sample. Good. As you can see here, it's implemented with Rx without interacting with event handler. The event approach of the WPF. Okay, so I will take a look on the inside on the code. Okay, here we are tracking the mouse drag. So the first stream is mouse downstream. The observable comes from the Rx, from event pattern, the old event pattern that we know, mouse button event args. Create a stream on the mouse down. Okay. This is mouse downstream. The second one is mouse move stream. So create another stream of the mouse move. The third stream is mouse upstream. Okay. So we join together with the LINQ here. So mouse down, select start line in order to inform that we are starting new line or new character or new drawing line, polyline. Here is merging, select menu with mouse move. Okay, so this is another operator. By the way, all these are operators of Rx. Take until mouse up. Okay, it's expressive here. So select, start with mouse down, and select all mouse move. Take the mouse move until the mouse up. Okay, so here do. Okay, in order to invoke the drag complex action here. Here the selection in order to transform these to the point to data, a new point here, in order to draw this point to the Drawboard, and finally subscribe. While dragging, let's have a look on the drag this method draw. So it's just to append the new point to the current line that we are drawing. Okay. Give me a sec to execute this sample again. I want to show something here. Yeah. when I'm hitting the mouse, so the mouse down, and keep it hold and move, and move out. Yeah.
I cannot see the application. Probably it's a sharing problem, or it's just me.
Maybe I share only Visual Studio screen, so I have to share the whole screen. Sorry. Yeah. Okay. When I'm mouse down and click, hold, move. When I'm go out of the board or the area of the board, and I still having the mouse down. When I release the mouse and return back to the mouse button, this is an issue. Sure. Okay, I will show how it is easy to extend and fix this issue with adding only one operator here, mouse move stream. So it's with the mouse move stream. So we have to add here as get position. So where is the stream itself? Okay, here we have to take and all. This is we have to use the take while. Sorry, take while operator. Okay, x go to x dot event args here. Left button pressed. Okay, so when the mouse released, stop taking the points. Let's see if the issue is fixed. Okay, yeah, the issue was fixed only by adding this operator. So we can play with operators. Okay, I want to show another thing here with the presentation, how we trim the stream itself. Okay, I will share the presentation again. Give me a sec, please. Good. The second one, oops. Yeah, here we can see this. The second stream is mouse stream trimmed, so it's starts with the mouse down and ends with the mouse up. So these slide show visually how we did with take while operator. Okay. So in order to go deeper with RX, you can have a look on these references, especially the intro to rx.com and another book. It's a great book, rx.net in action. Okay. If you want to take a look at these samples, you can find it on the GitHub repository. Finally, let's go with Q&A session. If anyone have a question, I will do my best to answer the question. Actually, I'm not an expert in rx.net, but I will do my best.
Yeah, guys, feel free, because there was quite a pause in this in our meetups. I need to remind that the main benefit to participate is to be able to talk to each other. So I actually, when I do talks, I prefer to allow questions alongside with the talk. But anyways, feel free to use this chance. And if no, I think, Abdurazak, we have some time to also go with your last sample. So if there are no questions, people are shy or don't want to actively participate, we have some more time to go with the last sample that you scoped out.
I have not a question, but a request. Could you please share the link in the chat for repository just to be more familiar with the code?
I'm gonna make sure that you have these materials after. Do you need it right now or?
No, just to have it.
Yeah, I will make sure to share all the materials. There's gonna be a recording and and either the links or the presentation, I don't know, whatever Abderrazak decides.
Okay, thank you.
No worries. Are there any other questions? If no, Abderrazak, what do you think about showing the last sample? Because in my understanding, it's a very interesting domain, and it's good to have more examples of real life applications, or at least closer to real life.
Okay, let's go with the NuGet search sample. Okay, I will share my screen. It's good. As I told you, this sample, it's not mine, to be honest. I picked up this one from the RX samples repository, but I found that it is very interesting. So with WPF, implemented with WPF. So there is an older library called Reactive UI built on top of rx.net. So in action, we deal with Reactive UI library, okay, not directly with the Rx library itself. So it is an implementation on top of the rx.net. Okay, here we're implementing the MVVM pattern. So this is the view. I don't know if guys have an idea about WPF itself. So this is the view with XML language, Microsoft technologies. And here is the view model. Okay, so the idea of this sample is looking or filtering or searching in the NuGet server, okay, the Microsoft NuGet server. You know, when you filtering or searching in a huge number of libraries like NuGet, you have to implement some mechanisms, okay, to make your application more powerful and performance. Okay, especially when we type, for example, when we are typing the package name, it is not good idea to go to the server and apply the filter when each character typed. So we have to implement some mechanism to delay the search or to delay the invoking the query to the server. So Rx will help us in this term. Okay, in these four lines, we have a lot of operators implemented or used here. So they come as extensions. The base type here is reactive object, comes from the Reactive UI library. Okay, so the first operator is when any value from the search term. The search term is the filter string that we type on the text box. Okay, so when any value from the search term, so when the user typed any value, any character, we have to implement throttle here operator in order to ignore the elements that comes from the observable sequence, okay, which are followed by another elements as described here in the documentation of the operator itself. Okay, so we want to ignore some values that comes after a delay here. Then we have to select the non-empty result, then distinct interval changed the distinct value. So when the two values are equal and comes in different times, so we have to ignore them in order to take only the distinct values. Also here, where operator, it comes from LINQ, sure, to filter the non-empty one. Select many here to merge the result, to invoke the search NuGet packages here. Let's have a look about the search NuGet packages. This is the method that invokes the NuGet server itself to get the result. Okay, Then observe on another operator to specify the concurrency. You know, when we playing with multitask, so we have to specify the dispatcher or the scheduler itself. So here we are playing with the concurrency. You know, by the way, the .NET Rx will help a lot about managing concurrency. Two operator. This is not Rx operator, but the reactive UI library operator, in order to map the result to this property. So when finished, the result is ready. So we have to put the result into this property. Okay, here is an idea about how we manage the errors, okay, with Rx, with non-blocking way. So when, so you see here, also the error handling comes as an observer. Okay, so we have to subscribe to the error handler. Also here, using another operator to switch the UI properties. So for example, when the results are ready, so we have to change the is available property to true. So yeah, we have available results. If the results are, such results are null, for example, we have to say we have not available result. Okay, so when any value in search result, so we have a value here, okay, and with different at null, so map the result to available. It's kind of converter, playing as a converter. So in order to execute this sample, because I have a security issue, I couldn't execute this sample on APAM workstation. Okay, you can see here the, oh, yeah, finally it is executed. Okay, so you see here number, for example, 2 words. I'm looking for number 2 words extension. Okay, you see the filter invocation comes after when I finish typing all the filter number 2 words. Okay. For example, let's remove some character here. Okay, you see with delay, so it is kind of optimization. Play with rx.net. Okay. I think I finished the sample.
Okay, guys. Yeah, I guess the core of the talk is close to an end. Okay. Does anyone have any other questions? All right, then I will be stopping the recording. So the